Confused to me. I was saying the worst case would be largest box, flat lines.
Right. Exactly.
Two boxes, flat lines. Now is 32?
Just a couple of seconds, it'll show you.
This is going to be two boxes, right? Because you're at 32.
Well, what it does is it scans half of the memory, so it'll be a very, very smooth curve showing the data.
Meaning?
So yeah. See, that's how it's smooth. So you can see over on the right-hand side, out in this area here, there's not nearly as many bits as there are in this part over here.
Right.
So what's happened is it takes 50%, takes a window that's half the width of this,
right,
and slides that window slowly across here.
Right.
It gets 50% of the data at any one time.
Right. And so
this is defined as being 50% is as large as we felt was ever usable.
So at this window, if I'm understanding, so we have we sort of have a sort of like a baseline, which if you want to be real tight is at 300. If you want to give us some credit, give us, say, 200. We might have a signal to noise of maybe 2 to 1 here, probably a little bit less.
Yes, although
except for this.
I think my inclination for defining signal to noise would be. Let me go back here.
Go back to some reasonable window.
Let me show what I think may constitute our baseline.
Yeah, because I was taking the worst case window, right?
You're right. I think when you have most of these points right here off of the baseline. Now this doesn't count out here because it's at the end, and this doesn't count here. But along here, where the scan is moving along, once these have moved up off the baseline, this is probably where your best signal to noise is going to be. I would say in this case our noise level would be averaging about 40 to 50.
Mm-hmm.
And our peaks of our signal are in the 140 to 150 range. So we've got about a 3 to 1 noise ratio on this one.
Uh-huh.
This is kind of like, you see how this is kind of like noise down here.
Yeah, I agree.
And we're going to, and that's what we're probably going to start looking for is like, how do you figure out what that baseline noise is?
Right.
Another way to do it, and we may eventually want to put this in here, would be to have an adjustable line that you set a threshold, like you set a threshold right here, and then anything that pokes up above that threshold is signal, and everything below it is noise.
Yeah, let the researcher decide.
Yeah, exactly. But somebody's going to have to figure out what this stuff means in order to really determine some of that stuff. In this case here,
we're still about 140 to, let's say, 60, so...
Well, here's the question.
2 to 1.
Signal is the real question, you know? These things here and there, and there, and there, and there, they're sort of evenly spaced, and we don't have enough experience with these memory chips to know whether or not this might be signal.
Yeah, it would also be very suspicious because of the even spacing as some sort of whatever array susceptibility.
Yeah, exactly. Some sort of anomaly. So at this point, I think we really need to just get some experience with these chips.
Yeah.
And the researcher is going to have to figure out what this stuff means.
Okay, so my question is there a way besides visual memory to kind of compile the record